in this video we are going to look at a very common mistake that people make while starting with their programming journey. So that mistake is using an is equals to operator along with floats or doubles. So why using is equals to compare two different floats or two same doubles or floats is a problem, because both of these types, double and float, are precision based types. Okay, so they have, like, you could say a 64-bit double or a 32-bit float is there. So float is a single precision and double is a double precision, which is 64-bit, and single precision is 32-bit. Okay, so in that we have two parts. One is the exponent part and other one is the mantissa part. So the mantissa part is the things that go after the decimal point, okay, which are the approximation, and the exponent part is the one that is in the the left side of the decimal point. Okay, so that is how things are stored in that. But again, what happens is there is a limit to the values that could be stored. Okay, so sometimes we have cases where recurring values in binary patterns occur in that part. So those things cannot be effectively handled. So in those cases, round off takes place. So that round off causes approximation errors. So this is one example where that approximation error occurs. Okay, so let me just show you this example. So here the program that we have written is, we have declared three doubles, 0.1, 0.2, 0.3. Okay, then we have a if condition that compares a plus b to c. Okay, so ideally if we see 0.1 plus 0.2 is 3, but when we compare it to the c, that is 0.3, we get not equals. The reason being, when we store 0.3, the number 0.3 in itself is not stored at 0.3, it is stored in an approximation. Okay, so that approximation in itself is stored at 0.29999. So there is a course of error while storing that data. Okay, so that course of error is not considered. That is why we are getting the values as not equal. So this happens in cases where a small difference, which is very very small difference, occurs between two values. So how do we handle this problem? So for that we have another program. So here what we do is we introduce a constant tolerance. Okay, so which is a very small value. Okay, so that very small value is checked whether the difference between these two values, okay, so the result and the comparator, the difference between these two values is checked. So here we are using float absolute, which will give us the absolute value in float. Okay, so here we do a plus b minus c. Here we have this three constants that we have defined, not constants, three values that we have defined, and that we are checking whether the difference between these two values, that is the a plus b, which is the one part of the comparison, and c is less than epsilon. So if that tolerance difference is very less, okay, then you could consider it equal. Okay, so what value of epsilon you should choose depends on the kind of application you are making. If you keep the value of epsilon very higher, okay, so if you keep it at like 10^2, 10^3 or that sort of a thing, sometimes false positives might occur in your calculation. So that will be a problem. So here we have taken the value very small, it is 10^-9. Okay, so that is why we are able to handle this thing. So the point is where this problem occurs. So many times we serialize the data, and across multiple devices we are sending the data, like we are sending from one computer system to another. So in some cases there are things like endianness, or you could say how floating point arithmetic is done on that system. So like some systems do have special hardwares for floating point arithmetic and all those things. So some of these hardwares work in some optimizations or other things, so that might not handle the conversion properly. So serialization is one issue due to which you could have a small difference. Okay, so here we directly were using comparison, but in the long run you could have this issue while you are doing computations as well. Okay, so that is reason why in financial institutes and all those places where the values matter, okay, they use either fixed point decimals, okay, or they use like numbers only directly. So like they have dedicated decimal types, like in SQL you have a decimal and numeric types which allow you to define, you could say, the mantissa and exponent part. Okay, so that way you have that flexibility. And fixed point decimal, you store the values in a higher precision, rather not you're excluding the precision itself. So if you want to store like a value, say 1.20, then you store it as 120 itself. Okay, so that sort of a thing. So this is how these errors are handled. I hope this might have given you an edge, or you could say it might have helped you in some way or the other if you are not aware of this. And if you're already aware of this, yeah, I already did this mistake when I started out, so I just hope no one else has to do the same mistake and he can probably be helped by this video. Thank you.